Okay, I'm going to go over the answers to the 2.1 quick check. So the first thing here is like that chart we had about protons, neutrons, and electrons. So if I had the mass of one AMU, you should say, oh, okay, that is protons, but that's also neutrons. They're both mass of one AMU. Who has a charge of +1? That is just protons. Forms a nucleus as protons and neutrons. Is changed to form ions. Ions, that's going to be electrons. Contains very little mass but occupies all the volume. Okay, that's electrons again. So with those ideas, you should go think to yourself, well, what are some other kind of questions we can ask? So like say, well, who has a mass that's much less than 1 AMU? That'd be electrons. Who has a charge of -1 or 0? Which ones are outside the nucleus? What if you were to what would change in order to form isotopes? Or what would change in order to form a different element? So those are ideas you should think about. Okay, for the second part here, okay, here we have two symbols. Okay, so the idea, are these different elements? And the answer, no, they're both calcium. Okay, are they different isotopes of the same element? Yes, definitely. Okay, because they're the same element, but they have different masses. Okay, are they different ions? No, because they're both, say, +2, so they're both the same ions. So they are the same ion of the same element. Okay, next part here, writing the isotopic notation. So if we were to tell you that we had 27 protons, 33 neutrons, and 27 electrons, well, first off, we have to go to the periodic table and say number 27, there it is, cobalt. So we know that symbol. So this guy is going to be cobalt. The 27 goes down here. We've got to add those two together to get the mass number. So together that adds up to 60. And now we look at these two, 27 protons, 27 electrons. So there is no charge on this, so we just simply leave that right corner blank. So that's the answer for the first one. Okay, 55 protons. We have to look around there. We see there it is. It's cesium. So that's our symbol. So we say cesium. Bottom number is 55, number of protons, the atomic number. We have to add those two together, so that's going to be 135. And now this time we look at these two. I've got 54 negative electrons and 55 positive protons, so this is going to have a positive charge. And that's that answer. Now the next one is kind of the opposite around. Okay, if we start with the symbol, figure out the protons, neutrons, and electrons. So if we say we have magnesium, okay, magnesium, we got to go find that here. It's number 12. Okay, so the bottom number is going to be 12. So we know that there are 12 protons. This guy here has 26 total protons and neutrons. So if we subtract those two, we would say we have 14 neutrons. And the last part here is there's no charge on that element. Okay, there's nothing up here in the corner. So that means it must have the same number of electrons as it has protons. So these two balance out. That's why there's no charge. Okay, we'll do the next one, sulfur. So we've got to find sulfur. There's sulfur. Okay, number 16. So that means we know that it has 16 protons. We could write that down here at the bottom. Okay, 35 minus 16. That sounds like 19 for the neutrons. And it has a -2 charge. So these protons are positive, the electrons are negative. If it's -2, it must have 2 extra electrons compared to the protons when we compare those two. So that's why it's a -2 charge. Okay, and the last problem down here is talking about silver 107 and silver 109. And I wanted to point out really quickly, you might see this several different ways. You could say silver 107 or 107/47. That's the isotopic notation. But you might also just call that silver 107 or write it out, silver 107. And that 107 is talking about the mass number. So we've seen before, we just set this up. We say the concentration times the mass divided by 100. And when we get done, we get 108.96, I believe, AMUs. And that might be wrong, but people are talking, so I'm stopping now. And that's the quick check.